Hi, I'm Vishnu, and with the help of Kannan, we are going to teach you about phase changes of matters and phase change calculations. First, what are the phases of matter? The most basic definition is that matter can exist as a solid, liquid, or gas. To explain this, we can look to water. Water is in the gas phase when it is steam. It is in the solid phase when it is ice, and normally we use water when it is in the liquid phase. But why is this possible? Water and other substances can exist in multiple phases because of changes in the structure of their molecules. Phases are influenced by certain factors such as pressure, temperature, kinetic energy, and intermolecular forces. An intermolecular force is a force which occurs between the molecules instead of within them. Let's start off with the solid phase. Substances in the solid phase have molecules which are very close together, and compared to other phases have molecules which are not moving so fast, i.e. they have low kinetic energy. The strong intermolecular forces holding the molecules together explain the decrease in speed of the molecules and cause a solid as a whole to be dense. With the tightly bounded molecules, solids cannot change in volume and shape. Next, we move on to the liquid phase. Liquid substances share similar properties with solids. Both liquids and solids have definite volumes, and their molecules are relatively close together. But liquids are unlike solids because their particles are free to slide past one another due to significant molecular motions. Liquids have strong IMFs, however, because of the rapid molecular motions, liquids do not have a definite shape and are free to take the shape of the containers that they are in. Liquids have specific properties such as viscosity and surface tension. When spilled, liquids tend to bead up. This is because the IMFs of the liquid resist an increase in surface area. The IMFs prevent inner molecules of the liquid from moving to the surface. Viscosity is a measure of the liquid's resistance to flow. The higher the IMFs, the higher the viscosity. Lastly, we move on to gases. Gases have no definite shape and volume, and they expand fully to the container that they are in. Here, the molecules are very far apart and are moving very fast. They have high molecular energy. Thus, the gases have negligible IMFs. This also makes the gases the least dense phase. When moving through phases, we can see that solids have the least kinetic energy and gases have the most kinetic energy. Therefore, to move from a solid to gas, we must add energy or increase the amount of kinetic energy. In the diagram, the length of the arrows suggest how much energy is required to shift phases. So it takes more energy to go from a liquid to gas than from a solid to liquid. Also apparent is the blue arrows. Here, the phases are going from gases to solids. In order to do that, we must decrease the energy or decrease the amount of kinetic energy within the molecules. This makes sense because in nature, liquids have less kinetic energy than gases. Specific phase changes have been labeled with their respective names, i.e. going from a solid to liquid is melting. Special cases such as going from a gas to a solid is called deposition, and this requires a decrease of kinetic energy. Similarly, sublimation is when a solid changes to a gas. When doing calculations for phase changes, we will encounter terms such as heat of fusion and heat of vaporization. They're used because matter requires an amount of energy to be put in during a phase change to overcome the remaining cohesion forces between the molecules. Heat of fusion is the energy required to change a solid at its melting point to a liquid. The heat of vaporization is the energy required to change a liquid to a gas at its melting point. When in transition, we use the heats of fusion or melting multiplied the moles of the substance to get the energy required to change phases at the specific points. Do not forget, energy must be added or taken away no matter what phase the substance is in order to get the substance to a certain boiling or melting point. These are the specific kinetic energies which allow the molecule to rearrange and change phases. We use Q is equal to mc delta T to get the amount of energy Q to reach the nearest boiling/melting point. M is equal to the mass of the substance. C is equal to the specific heat capacity. This is a measured property which is defined as the energy required to raise the temperature of 1 gram of substance by 1 Celsius degrees. Delta T is the change in temperature, so the final temperature minus the initial temperature. Now let's do some practice problems. Some useful information to consider is the heat of fusion of water, the heat of vaporization of water, and the specific heats based off of the phases. Number 1. What is the amount of heat required to change 25 grams of negative 10 degrees Celsius ice into 150 degrees Celsius steam? First, we must use Q is equal to MCAT to find the amount of energy required to heat ice to water. Q is equal to 25 grams, which is the mass, times 2.09 joules over grams Celsius, which is the specific heat of ice, times 10, or the change in temperature. This equals 522.5 joules. Next, to account for the last remaining cohesion forces, multiply the number of moles by the heat of fusion. Q is equal to 25 grams, the mass, times 334 joules over grams, which is the heat of fusion of water, and this equals 8,350 joules. Next, we must find the energy needed to heat water from 0 degrees Celsius to 100 degrees Celsius. Q is equal to 25 grams times 4.18 grams over joules times 100. This is the mass times the specific heat of water times the change in temperature, and this equals 10,450 joules. Step 4, we must convert the liquid to steam. This is 25 grams, the mass, times 2,257, the heat of vaporization of water, and this yields 56,425 joules. Next, step 5, to heat steam to 150 degrees Celsius. Q is equal to the mass, 25 grams, times 2.09 joules over grams, which is the specific heat of steam, times 50, the change in temperature. This equals 2,612.5 joules. Finally, we must sum the individual energies. 522.5 plus 8,350 plus 10,450 plus 56,425 plus 2,612.5. This equals 78,360 joules, or 78.36 kilojoules. And this is the amount of heat required to change 25 grams of negative 10 degrees Celsius ice into 150 degrees Celsius steam. Practice problem number 2. What is the amount of heat required to change 10 grams of water at 17 degrees Celsius to steam at 103 degrees Celsius? Step 1. We must find the amount of energy required to heat water from 17 degrees Celsius to 100 degrees Celsius. And we do this by using Q is equal to MCAT. Q is equal to 10, the mass of water, times 4.18, the specific heat of water, times 83, or the change in temperature. This is equal to 3,469.4 joules. Next, we convert water to steam. This is equal to 10 grams, the mass, times 2,257, or the heat of vaporization of water. This is equal to 22,570 joules. Next, step 3. Find the energy needed to heat steam to 103 degrees Celsius. Another Q is equal to MCAT. Q is equal to 10 times 2.09 times 3, and this is equal to 62.7 joules. When we sum them up, 3,469.4 plus 22,570 plus 62.7, we get 26.10 kilojoules. And this is the amount of heat required to change 10 grams of water at 17 degrees Celsius to steam at 103 degrees Celsius. Now you're all set on phase change calculations. Thanks for watching.